Okay, now let's look at this part of the code, which is basically my interrupt subroutine. Now in this process, in the interrupt subroutine, the first thing that I am doing is I am pushing all the values of my registers and pushing the program status word, which is basically register A and the flag register. And then after pushing them, I am going to do something related to my interrupt. So over here I am simply changing the values of my registers. Then I am again going to pop all the registers back, including the program status word, which consists of register A and the flags. Then I am going to again turn on my interrupts, the global enable interrupts, and then I am going to return. So I am going to return back to wherever I had left. Okay, so remember that after we write the same instruction, we will have to write enable interrupts assembly language instruction. Only if I have written this instruction, only then my RST 6.5 interrupt is going to get activated. So which means if I press the button RST 6.5 and only if I have done an EI before this, only then the microprocessor is going to accept the interrupt occurring at RST 6.5. So which means the interrupt can occur anytime that I am over here, meaning only after the EI is executed and I am actually in my main program, I am over here, and if the interrupt RST 6.5 occurs, then from here I am going to actually jump to this particular instruction subroutine, execute the instruction subroutine, and then I am going to return back to the place that I had left. Now please note that while I am looping in my main program, the value of B obviously will start from FF and it is going to decrement with each and every instruction as I move through my loop, which means the value of B is going to be anything which is less than FF while this loop is running. Now meanwhile, if my instruction RST 6.5 occurs, then which means I am going to go here. Now as soon as I go here, I will be pushing the value of B and C. Okay, after that when I am executing this, please note that I am loading a 0 into the value of B, which means I have changed the value of B, which means my interrupt subroutine has changed the value of B, and it is not the same value of B that was there when I was actually executing my loop, which means it has disturbed the value of B in the loop. However, I am safe because later on when I do the pop B, it is actually going to load back the value of B that I had pushed earlier when I had entered the interrupt subroutine, which means even though I have changed the value of B here, whenever pop B occurs, which means it is going to load back the value of B which was present when I was executing the loop inside my main program.